Friends, today's session is session 3. In the last session, we have discussed about the production of nitric acid, the methods of production of nitric acid. There are 4 methods: the ammonia oxidation process, ammonia, that is nitrogen fixation process, by using radiation process. Actually, most of the nitric acid is produced from ammonia oxidation process. We have seen the raw materials required for that. That is, ammonia is very much required. Then a catalyst, platinum rhodium catalyst is required, and air for oxidation. We have seen the chemical reactions. We have gone through the process flow sheet or flow diagram, whatever it may be, and we have seen various stages of operations, and in detail we have discussed about the chemical process that is happening in the plant of nitric acid. Today in this session we are going to discuss about the production of phosphoric acid. First we'll discuss about the methods of production. There are 4 methods of production of phosphoric acid. That is, one is wet process. In that wet process we have strong sulfuric acid leaching process, and second one is hydrochloric acid leaching process. That is, Israel mining industries, they have developed this process, so it is known as IMI process also. Then electric arc furnace process, where direct conversion of phosphate rock into phosphoric acid takes place there. And fourth one is oxidation and hydration of elemental phosphorus. This process is actually used in the remote areas from the major phosphoric acid manufacturing plants. To meet the small customer requirements, the oxidation and hydration of elemental phosphorus is done. Then we'll see the raw materials for wet process, that is strong sulfuric acid leaching process. Here high grade phosphate rock is necessary, that is to avoid solubilization of mined rock impurities such as aluminium, silicon, iron oxide, and alkali minerals. The another raw material required is strong sulfuric acid from contact process. So these two are the major raw materials required for the production of phosphoric acid by sulfuric acid leaching process. Next we see the chemical reactions. The calcium phosphate, that is Ca3PO4 twice, is made to react with strong sulfuric acid H2SO4 and water. It gives phosphoric acid, that is H3PO4, and hydrated calcium sulfate. Hydrated calcium sulfate is obtained as a precipitate in the solid form. This is the major reaction. Side reactions also taking place because of the variations in the process conditions and also the other impurities that are present in the rock phosphate. The side reaction is rock phosphate also contains calcium fluoride, which actually reacts with sulfuric acid and water. It gives hydrogen fluoride and hydrated calcium sulfate. This hydrogen fluoride is further converted to hydrogen silicon fluoride by treating it with powdered silicon. So these are the chemical reactions which occur in the process. This is the flow diagram for the production of phosphoric acid from phosphate rock. In brief, I will explain this flow diagram. Right? The phosphate rock is ground to fine powder, and it is actually metered and fed to the reactor. This is actually a reactor which is provided with agitation and agitators and all. And here the concentrated sulfuric acid also fed into the reactor. So this is an exothermic reaction. Heat is evolved. The overheating of reactor occurs. To eliminate that heat of reaction, cooling air is blown across this reactor. And here the reaction takes place and a mixture of phosphoric acid and calcium, hydrated calcium sulfate is formed. This mixture is taken to a traveling pan filter press where the phosphoric acid is separated from the hydrated calcium sulfate. The hydrated calcium sulfate is actually obtained as a filter cake which is washed with hot water to separate the entrained phosphoric acid in the filter cake. The filter cake is taken, washed, and it is used in the production of gypsum, or it can be discarded into slurry lagoons. The filtrate from this contains some finely divided solid particles, and it is actually taken into a storage tank where the solid particles actually settle, and the overflow is taken and as a 40% concentrated phosphoric acid. If the higher concentration is desired, it is actually fed to single effect evaporator, wherein the concentration, that is the water content in the phosphoric acid, is removed by the evaporation, thereby the concentration of phosphoric acid is increased to 75%. It is taken out from the bottom of the single effect evaporator and it is used here, right? So this is up to here. The process is up to here only, right? That is to produce phosphoric acid. The rest of the part of the process is manufacture of this fertilizer, right? That is not required in this contest. So you have to study the flow chart up to here one, up to 75% concentrated sulfuric acid which is obtained. The rest of the process, this part is actually omitted. This is actually required to produce the mixed fertilizer from phosphoric acid, right? The process goes like this. The phosphate rock is ground to 65% to pass 200 mesh screen and fed to the tube where the recycled stream of weak phosphoric acid washes into a reaction tank. Strong sulfuric acid is metered with automatic control which keeps the acid and the rock feed ratio in the desired setting. A single reactor can be designed by proper baffling and residence time capacitance to permit a 98% conversion of phosphate rock into phosphoric acid in 4 to 6 hours. In the other designs, a series of 4 to 5 continuous mixing tanks can be used with slight better efficiency of extraction by minimizing back washing. The heat of reaction is controlled by pulling or blowing cooling air across the reactor. The gypsum phosphoric acid slurry goes to a traveling pan vacuum filter where 40% concentrated phosphoric acid is removed and the cake form, that is hydrated calcium sulfate, is washed in water, filtered, and it can be sent to gypsum production or it can be sent to waste lagoons. The filtrate from the traveling pan filter press is returned to the reactor. The dilute acid is then concentrated in single effect evaporator to any grade more than 50% acid content. Most of the wet processed acid is being converted to high concentration chemical fertilizer. The acid, phosphoric acid obtained is known as orthophosphoric acid. Pyrophosphoric acid, that is H4P2O7, can be made by heating the orthophosphoric acid to about 250 degrees Celsius. By increasing the temperature beyond this, up to 900 degrees centigrade temperature, metaphosphoric acid results. This is the process which is taking place in the production of phosphoric acid by sulfuric acid leaching process. Next, we will discuss the another wet process, hydrochloric acid leaching process or IMI process. Here, the raw materials required are phosphate rock of high phosphorus pentoxide content, more than 30% is preferred to avoid excessive acid consumption. Hydrogen chloride gas or concentrated aqueous hydrochloric acid, more than 30% concentration, is used, or a waste acid, that is from a byproduct, can also be used. Another raw material required is an organic C4 or C5 alcohol as solvent, which is used to extract phosphoric acid from calcium sulfate solution. I mean to say calcium chloride solution. Right. Then we see the chemical reactions that are taking place. Here, rock phosphate Ca3PO4 twice, which also contains some extent of calcium chloride, also CaF2. This rock phosphate is treated with hydrochloric acid and water, which produces phosphoric acid and calcium chloride. Some side reactions also takes place, that is the calcium fluoride, which is present in the rock phosphate, reacts with hydrochloric acid and water, which produces hydrogen fluoride and calcium chloride. This hydrogen fluoride further reacts with powdered silica to convert it into hydrogen silicon fluoride and water. Thus, this hydrogen silicon fluoride gets precipitated and removed by filtration from the water, and it can be discarded. Next, we'll see the process flow sheet. This is the process flow sheet for the production of phosphoric acid by hydrochloric acid leaching process. In brief, this is the reactor wherein phosphate rock is ground and fed to reactor where hydrochloric acid from the storage is fed into that, so that the reaction takes place in this reactor and the product, that is phosphoric acid, calcium, hydrated calcium silicate, unreacted phosphate rock, everything will be then washed in counter current manner in the 3 washing thickeners. It actually washing is done in counter current manner, and the phosphoric acid is actually along with calcium sulfate and or entrained calcium sulfate, hydrated calcium sulfate, is actually taken as overflow from the first mixer settler, and it is sorry, it is a treatment tank. It is fed to a series of mixer settlers, four mixer settlers, A, B, C, and D. In the first mixer settler, the calcium ions are actually separated here, and then it goes to second mixer settler where calcium ions are separated here, and then it goes to third mixer settler where sulfuric acid, sorry, phosphoric acid is separated by extraction from hydrochloric acid by extracting with water. Water used as an extractant there. So the hydrochloric acid is separated from phosphoric acid here, and the phosphoric acid is taken out and fed to triple effect evaporator to separate the hydrochloric acid vapors, entrained hydrochloric vapors here. Right. The calcium chloride slurry, which is formed in the reactors, actually flows from first mixer settler to last mixer settler, where it is washed and fed to a separator where calcium chloride is separated and it is discarded. The acid streams, that is phosphoric acid and hydrogen chloride acid, these are actually get separated here. The hydrogen chloride gas, hydrochloric acid, weak acid is separated as overhead in the first effect evaporator, and in the second effect evaporator, concentrated hydrochloric acid is separated, which is used as makeup in the production of in the production or the conversion of rock phosphate into phosphoric acid, and finally the concentrated phosphoric acid is taken out from the bottom of the third effect evaporator as a product. And the process goes like this. Phosphate rock is ground to pass a 20 mesh screen and fed into a dissolver where an acid stream of concentrated HCl plus makeup wash water from the counter current decantation system is added. The fumes of carbon dioxide, hydrogen fluoride, and unreacted hydrochloric acid are scrubbed for acid recovery, that is, recover HCl from these fumes. The mixture is then fed to a series of decantation units with overflow from first settler moving to the counter current solvent extraction operation. The solids underflow goes to second to third washing thickeners. The extraction of phosphoric acid plus some free hydrochloric acid is done in batteries of mixer settlers in aqueous phase. The extract again is passed through several mixer settlers B for the removal of calcium ions which are co-extracted. The extractant is an aqueous reflux from the next unit is transferred to the extractor C where water extracts phosphoric acid from hydrochloric acid from the solvent phase. The washed solvent is recycled to a final series of mixer settler D where the balanced HCl is extracted from raffinate phase of extractor A. The acid-free brine is sent to steam stripping for solvent recovery. The aqueous acid raffinate from C is separated and concentrated in a multiple effect evaporator to give different overhead streams like number one, alcohol, water overhead flash from the first effect, which is condensed and returned to the extracted A. Second one, the dilute HCl from the second effect evaporator and concentrated HCl from the third effect evaporator. The HCl is returned to acid makeup plant. The bottom from the third effect evaporator is the product phosphoric acid of 80% concentration. Now we'll see the properties of phosphoric acid. The molecular weight of phosphoric acid is 98, melting point 42.4 degrees Celsius, boiling point 1 to 13 degrees Celsius, density 1.83 gram per cc. It is completely miscible in water. Next, we see the applications of phosphoric acid. Phosphoric acid is used in the manufacture of fertilizers. It is also used in the production of soaps and detergents and in food chemicals. In India, 90% of the phosphoric acid produced goes to fertilizer production. So this is briefly about the production of phosphoric acid by sulfuric acid leaching process, hydrochloric acid leaching process. We have seen their flow charts, chemical reactions, raw materials required, and properties and applications of phosphoric acid. Thank you.